Welcome to the course on audio signal processing for music applications. In the last programming class, we introduced Python, which is a high-level language, quite powerful, and that's going to be very useful for us for all the applications and for all the programming we will have to do. In this lecture, I want to talk about how to use Python to process sounds, how to read sound files, process sounds, and then write sound files again. So let's start by going to a terminal. And now starting the interactive shell that we'll be using to program in Python, which is IPython. And now we have to read a sound file. Okay, to read a sound file, we need to use one package, SciPy, that has this functionality. So what we're going to do is from SciPy, and within SciPy there is a module called IO, and within that there is one specifically to handle WAV files. So from that part of this package, we're going to import the read function. Okay, so now the read function is part of our system, Python, and in fact if we type help and the read function, it knows about it and it tells me what is the input and the output. So as input, we're going to input the name of the file I want to have, and then as return, what it returns is the sampling rate and an array with the actual samples of the sound. Okay, so what we're going to do is have fs as a variable where to put the sampling rate, x as a variable where to put the samples of the sound, and then we're going to say read, and we're going to put a file name here. Okay, in this directory I am in, I have a file name called flute.a4.wav. Okay, so I will read this sound file into memory. Okay, so now fs has the sampling rate 44,100, and x is an array of integers. They are 16-bit integers, including all the samples. Here, of course, it's not showing everything, it's just showing the first 3 and the last 3. Now we can start asking things about this sound. For example, if we want to know the length of the array, we can just type x.size, and this tells me that this sound has 94,803 samples. If we want to know how many seconds that is, we can divide the number of samples into the sampling rate. However, these two numbers are integers, so the result is an integer. If we want to know the duration in an exact way, what we're going to do is just convert one of the numbers to a floating point number, like the fs, so that now it returns a floating point number. So this is the duration of the sound in seconds, so it's 2.149 seconds. Now we can plot the sound, for example. In order to plot it, we need to import the package for plotting, matplotlib. So we will import matplotlib, and specifically within that the pyplot module, and we're going to give it as a name plt. So now we can call the plot function within that module and give it the array of samples. In order to show it, we're going to have to call the show command. Okay, and this is the sound, the visualization of the waveform. In the horizontal axis, it basically has the samples I read, and then on the vertical axis, it has the values of these samples. Being integer values, it goes from minus 10,000 to 8,000. Okay, but this is not a nice way to visualize sound. What we want to do is to visualize them in seconds. So the time axis should be in seconds. How do we do that? Okay, so what we're going to do is we need to get some arrays, and for doing that we need to import another package, which is the NumPy. So import NumPy as np, and now we can use some useful functions from NumPy. Specifically, we can create a time axis. So we define a time axis t that uses a function of NumPy called range. And a range, what it does is basically creates an array of the length that I put in as input, going from 0 to that value. And then if I divide by the sampling rate, this will create basically an array of seconds of the size of the sound, but in seconds. Okay, so that I have t. And now if I plot the array t with respect to x, now I have, and then of course I have to show it, I have a much nicer display, because on the horizontal axis I have time in seconds. So I can go from 0 to 2 point some, and this is the duration in seconds. Within that, this figure, we can zoom into it and do quite a few things. For example, it has this option, which is zoom or rectangle, so we can select a region of this, and we can see the oscillation of the sound. In fact, if we do it a little bit more, we're going to see it and even more. We will see the individual periods, the oscillation of the sound. Okay, so that's quite good. We don't have to actually call the function with these specific numbers. So within the figure, we can already navigate through this sound. Okay. But also we can select samples with Python commands by choosing just the samples from a given array. So for example, if we want to have another array that is just one fragment of our input array, so we can say, okay, take just samples, for example, from 44,100, so that means from second 1 to, let's say, 45,100. So this is going to be 1,000 files, 1,000 samples that are going to be stored in Y. And now, of course, we can just, if we plot this Y, it will just show the these 1,000 samples. Okay, now we can start doing operations, for example, on this new array. And for example, we can just ask what is the maximum of these arrays. So there is this function called max from NumPy, that if we give it the array y, it gives us what is the maximum value. However, of course, we know that sound sort of oscillates around 0, so it has positive and negative values. So in fact, instead of doing that, what it makes more sense is to just take the absolute value of y, so that it considers also the negative values as values to be considered. So if we now type the maximum of the absolute value of y, it gives us a different number, which basically that means that this was a negative value that, of course, was higher in terms of absolute value than the positive values. And we can do things like sum all the samples of an array. Okay, so this is the sum of all of them. Of course, now it's negative because, again, it has some positive and negative. If we do the absolute value, it will be a completely different value. Okay, now that we know how to process sounds, now what typical thing we will want to do is to write the result, or write this new sound into a file. So we need to get a function to write sound files. So again from SciPy, so from scipy.io.wav file, we are going to import the write function. Okay, and the write function basically accepts as input values a name of a file to write. Then we need to give it the sampling rate, which is the same as the input, so fs. And now we can just put an array of numbers. So for example, this new y array. Okay, and that's it. We have created a sound file, and if we type ls, it's going to be in test.wav file. And from within IPython, we can play these sound files by calling Unix or terminal level programs or functions. So specifically, if we put the exclamation mark, and there is this function in Unix, this program called play, and so if this calls the Unix program play, and we can give it any file that is in this directory. So if we put the flute a4.wav, okay, it's playing this flute sound, and is at the same time is giving me some information about this sound file. Okay, so that's all I wanted to say. So basically, we have been talking about reading and writing sound files, and there is this package WAV file within SciPy that allows us to do that, and there is packages that allow us to process and to manipulate these sounds. So with Matplotlib, we can plot sounds, fragments of sounds, and with NumPy, there is a whole bunch of functions that allows us to process these sounds. And that's all for this class. So we have already introduced Python, and now we have introduced some basic functions to read, write sound files. And hopefully with that we can start doing some interesting things. But of course we have to learn much more. So I will see you next class. Thank you.